This, I think, Professor Sengupta referred to very kindly. I just quote, if you don't mind, from a book. I got very excited when I was writing that book about the mystery of cosmological constant. So since nobody understands very well, basically used to write in the form of poem. This is in Sthan, Kal, and Vishwalok. I am the cosmological constant, a nursling of the universe. I pass through galaxies, I change with time, and contemplate time and space in its infinity. But I cannot die. I am the cosmological constant. I accelerate the universe. The universe may shiver, but keep on expanding. I am the cosmological constant, but I cannot die. But I die with the universe. This is in Lin, and there is a beautiful sculpture, which is in a board form. Because of the gravitation of the sun, the light particle bends along the gravity, and that's what they're trying to say with the Einstein equation at the bottom. Einstein says scarcely anyone who fully comprehends this theory can escape from its magic. I would like to dare say that the word magic is used loosely. What he's trying to say is the beauty and aesthetics of that equation, which is a very, very high order. As one-line equation explaining the mood of the entire universe is not a joke. I come now to Satyendranath Bose. I think we underestimate him somehow because we don't study his work too closely. This is the derivation of so-called Planck equation, which led to Bose-Einstein statistics, which is well known. Einstein translated that from English to German and sent it to the German journal Zeitphysik. And he said, in my opinion, Bose's derivation signifies an important advance. And that stirs that equation of Planck. Satyendranath Bose was reminded by his longtime friend Meghnad Saha that Planck's law of black body radiation assumes a lot of hypotheses, and whether he should look into it to crack those hypotheses in proper rational terms, which he did. So, in fact, not only did he do that, in order to derive Planck's equation, he also introduced the spin of the photon. So in one paper, not only he discovered the Bose-Einstein statistics and therefore bosons, he also had quantum spin discovered inherently, which Einstein proceeded to strike off. And that is extraordinary of Einstein, one thought. Bose re-derives Planck's radiation law. Bose-Einstein statistics is born. Quantum statistics started its new journey. And the legend goes, story goes, why legend? Dirac, during his visit to Calcutta, great Paul Adrian Maurice Dirac, realized that too many persons were trying to get into a small ambassador car. So he said jokingly, don't worry, we are all bosons, we can fit it in, all of us. Because bosons don't have a problem, they can always get in, which led to discovery of Bose-Einstein condensate. I think the word bosons was conceived around that time. You see, bosons are photons. Now, if you look at the universe, anybody can think about the universe, not a problem. You need some solitude. Big Bang, expanding universe, the hiss of the expanding universe, and there is because of the hiss radiation, you can see the cosmic microwave background radiation permeating all over the universe. And the universe in the cavity of cosmic microwave background radiation. And this radiation across the entire universe are bosons. So bosons permeate through the entire universe. And it's an interesting calculation for students, what will be the total number of photons existing at the moment in the universe. So Satyen Bose once said before he became too ill that আমি তো সবই পেলুম মেঘনাথ কিছু পেল না, such is his modesty. Now I sort of thought that what he meant by that. What he meant, of course, is this simple fact that bosons are everywhere. Of course, Meghnad's discovery was a great discovery in terms of thermalization of the temperature of the star. The next slide kind of interesting historically. One day, Satyendra Bose was reminiscing about his Berlin days. Einstein had given him a problem to solve. Satyendra Babu told me, I thought about it for 3 days, and then I went to see him means Einstein, with my solution. Einstein went through it and said, well, this is not wrong, but not the way I wanted. This clue does not open up any new possibility. And now comes the crunch of insult. Please don't waste my time with such trifles. Devastating. In fact, Satyendra Bose, which is little known, was so devastated with that comment that he stopped doing work on theoretical physics for 12 years after that. Satyendra Babu's mind seemed to go back into the past, and for some time he did not speak. It seems to me that Einstein was probably busy with some other problem. And when he is busy with some problem, no other problem would bother him. This has happened to many people. They ask about some questions about which he has done a lot of work, but he will say, I don't know anything about it, because his concentration was exactly at that time with the work that he's doing. So being a genius has got the entitlement of being extremely rude to other people, which he was at that time. But Bose never lost his respect for Einstein, his guru, which is, I think, one very extreme example of ekolobho. This is Meghnad Saha's equation, I won't bore you about, but it's a very, very important equation in terms of astronomy, astrophysics, as you know it today. Dr. Kalam, you know everybody, used it for missiles, rockets tearing through space. We used it with all our modesty for work on microsecond universe. And the last word, of course, uttered by his classmate, S.N. Bose. Meghnad, sitting at home, has measured the temperature of the stars. It is beautiful and applicable to stars twinkling across the cosmos. This is Meghnad Saha, in whose name goes Saha Institute of Nuclear Physics. We are celebrating 125 years of Bose and Saha. But are we? How many of us know about it? We wretched scientists are pathetic, I would say. Absolutely pathetic. Some unknown actor, know only some people, we celebrate their 50th, whatever it is, 60th, whatever. But these two great giants who brought Bengal and India in the front of the whole world, 125th year, and we have forgotten. And that is really sad, breaks my heart. But anyway, I'm celebrating in my own way. I'm celebrating now. Now comes Heisenberg, German theoretical physicist, whose fundamental contribution is the uncertainty principle, that you cannot know the position and the momentum very well at any time, and introduce statistics in our understanding bluntly. Werner Heisenberg, on his way to Japan, had a very intense conversation with Rabindranath Tagore in Jorasanko Thakurbadi on his way to Japan, as I said. It's a long story. I write this thing to remind you that those days relationship between a husband and wife was on a different level. Mrs. Heisenberg describes one moonlit night we walked all over Heisenberg Mountain, and he was completely overwhelmed by the vision he had and trying to explain his new discovery to me. He talked about the miracle of symmetry as the original archetype of creation, about harmony, the beauty of simplicity, and the inner truth. Then she goes on to say, with smiling certainty, Heisenberg once said to me, I was lucky enough to look over the good Lord's shoulder while he was at work. It's a beautiful description of how overwhelmed Heisenberg was, having discovered the uncertainty principle which we just saw. Let's forget that. Paul Dirac, another great scientist, and there another great scientist assisting at Westminster Abbey in London, along with the newcomer, Stephen Hawking, who has just come and settled down there in the grave, very strongly that an equation which is very beautiful, he thought, must be right. This is the point. If the one equation is very beautiful and the other one is not so beautiful, and the beautiful one must be right. And he went on to say God must be a mathematician. Einstein, of course, didn't like God playing with dice, reprimanded by Bohr, stopped telling good Lord how to run the world. This incident happened in Princeton. Hawking was a cheeky fellow. Forgive me saying, my friend, he is a little older than me. I used to know him somewhat, both at Cambridge and then Caltech for a while. He was getting ill slowly. But all the evidence indicates that God is an inveterate gambler, and he throws dice on every possible occasion. And he goes on saying, God does not play with dice. Einstein says, considering a particle emission from black holes would seem to suggest God not only plays dice, but also sometimes throws them where they cannot be seen again. So according to Stephen Hawking, the universe is a very, very, very large casino. What a thought. Everything is chance. There's another thought. It's a better picture of Stephen Hawking in the earlier times. His great discovery of entropy of black hole related to the geometric area A of the black hole. Bound in a wheelchair, he conquered the world in a brief history of time. This is a joke, some sort of joke. There are scientists who happen only once in every 500 years, like Archimedes and Newton. And there are scientists who happen only once or twice in a century, like Einstein or Bohr. So Fermi, this marijuana saying to Fermi, Enrico Fermi, both Italians. So Fermi says to marijuana, but what do I come in marijuana? Marijuana says, do be reasonable, Enrico. I'm not talking about you and me. I'm talking about Einstein and Bohr. This is a sort of an internal squabble about the various status of great stalwarts. Now I talk about the romantic poets of the West, those who had some connection and feeling about science. Wordsworth, not a scientist poet, and this you know most probably. Sweet in the love which nature brings, our meddling intellect mishaps the beauteous forms of things we murder to dissect. But my favorite is Shelley. Shelley, curiously enough, although born at that time and died in an accident in the ocean where his boat capsized, but he writes about cloud. And look at the words, so captivating. I am the daughter of earth and water, and the nursling of the sky. I pass through the pores of the ocean and shores. I change, but I cannot die. For after the rain, when with never a stain, the pavilion of heaven is bare, and the winds and sunbeams with their convex gleams build up the blue dome of air. I silently laugh at my own cenotaph, but out of the caverns of rain, like a child from the womb, like a ghost from the tomb, I arise and unbuild it again. He's just describing cloud, which is sort of language which is lyrical, but at the same time there's a touch of science behind that, which I think is extremely moving. Richard Feynman, another great scientist, a very mercurial personality, who was standing against the ocean, suddenly occurred to him, I, an ocean of atoms, an atom in the ocean, dichotomy of micro and the macro. And of course, Alfred Lord Tennyson, you all know, a poem called A Character, with a half glance upon the sky, at night he said, quote, the wanderings of this most intricate universe teach me the nothingness of things, yet could not all creation pierce beyond the bottom of his eye. This part of the story I will finish with two great mathematicians One is a complete genius. I describe Srinivasa Ramanujam as a complete genius. A definition of a complete genius is he doesn't know why he's creating what he's creating. He just comes. And that is the touch of genius. You will see in a minute. And the English mathematician G.H. Hardy. It's well known, but I want to draw your attention to the beauty of this identity. Don't please worry about the identity too much, but see for a second how the number 3 goes all over the place. It comes and goes, and he just wrote it down. So there was a guy, gentleman, by the name of G.W. Watson, G.N. Watson. He wanted to unravel how did Ramanujam comes to this so-called identity. And then when he discovered, he says, gives me a thrill which is indistinguishable from the thrill which I feel when I enter the Segregatia Nuovo Capello Medici and see before me the austere beauty of day, night, evening, and dawn, which Michelangelo has set over the tombs of Giuliano de' Medici and Lorenzo de' Medici, trying to unravel Ramanujam's genius. Tell us about the body. Just fantastic. This is the famous Medici tombs by Michelangelo, day, night, evening, and dawn. If you think that in that 2 sculptures, day, night, evening, and dawn are all coupled into, then I'll give you a prize. I don't understand. I've seen them many times. But then I don't have the right eyes, right? You have to have the right eyes. Now we go to contemporary reality. Can I take a breath? Do you want to go out for a walk? Or shall I finish it here? The macro and the macro. So far, we've been talking about poetry, intermixture of poetry with science, and how science and poetry are intermingled in some sense, which we hardly recognize. Now we go into our own experience about the micro and the macro, macrocosmos and the macrocosmos. How to behold the characteristic of the macrocosmos, the universe, in macrocosmos of the nucleus. Witnessing the infant universe of the Large Hadron Collider, Geneva. I think Janathan Gupta mentioned this actually. It was a great joy some 20 years ago when he managed to get a foothold in this highly competitive CERN experiment. Big bang versus little bang. This little bang between 2 nuclei, like this, creates a situation where the energy is so enormous that is not exact, it's a sort of a replica or a sort of a mimicking the early universe microsecond after the Big Bang. And this is a computer simulation of how it happens. But just to give you a flavor, that's best I can do, that's matter on the left, and then you go to so-called electron and atom, discovered by Dalton at the end of the 19th century. Then Rutherford discovered the nucleus, in the middle the blue, and the proton and neutron eventually, and then 60s, the proton and neutron, it was thought to be conceived of quarks and gluons. So this is a reductionism of matter, from matter to quarks and gluons. At this moment, the knowledge bank of human beings stand at the most fundamental constituents to quarks and gluons, and the whole world is dancing around quarks and gluons. The ancient Hindus thought slightly differently. They thought that fire, water, air, and sky, akash, or vyam, shunno, consist and make out the entire world around us. I don't wish to go into the dichotomy between the two. Again, the same picture in a different way. It's a picture of the universe, and the quark-gluon plasma was mentioned, and that is about something like a microsecond after the Big Bang from the left-hand side. It's a picture way back in 1989. We were very young at that time, very ambitious, and he wanted to compete with CERN, which is not easy, because anything big or good you want to do, which is not the same as before, the funding agencies don't like that. Funding agency would like something that X has done Y, and Y would do Z, that's it. But if you say, I want to discover X, Y, Z together, they don't like that very much. It is a very hard business. Eventually, the top man solved it, the Prime Minister of India. I'm not going to that. It was a very exciting time in my life. You see, he's a huge beast. And you see the beast there, is an average European man. It's 58,000 pads with some wire inside, diagonally inserted, to pick up photons or light particles as signals. Again, light particles. This is across the Atlantic in Brookhaven National Laboratory, radioacoustic heavy ion collider. It's an accelerator which is colliding mode. One side, some particles are going, another side coming and colliding with each other. And that's called radioacoustic heavy ion collider. So Rick, we're about to collide, sir. So come, welcome. I think it's a good thing you have come at the right time, So this is something which we did some years ago. This is the experiment, one experiment using star detector. Now you may wonder what all these people are doing together. The 300 odd people all over the world. And the cynical people say, how do you know who has done what? So my answer to that to the Delhi bureaucrats is, it's the job of the leader to know who has done what. If they don't know, they are not supposed to lead. Get out, quickly. And all these guys from all over the world, different language, different religion, different background, they work in unison. So the motto was, there may be difference in this world. There may be fight and battle in Afghanistan, Arab, and Iraq, and so on and so forth. But ultimately, if you pursue science, believe it or not, all those barriers go, which is a fact. It was a wonderful experience to work, even in America. This is something we designed ourselves, and this is something we published, which I don't want to go into details, is rather recent, 2013. I know it's 5 years ago, but still 5 years is not a very long time in this game. So it's actually looking at the thermometric signals, to be precise, photon particles again, as signals of formation of something which exactly mimics the universe a microsecond after the Big Bang. And it has been a rather exciting time because you can see or feel what the universe was doing in the laboratory. So I thought I'll quote Tagore again. And there is actually a poem called Alo, which he translated. And some of my friends who are great critic of poetry, Tagore, they say, although he translated it, but it's very different from the original Bengali. Whatever it is, both the English and the Bengali is very nice. So since you're talking about light, so you quote this light, my light, the world filling light, the eye kissing light, heart sweetening light. Ah, the light dances, my darling, at the center of my life. The light strikes